All right, welcome everyone. Such a crowd here, and I'm coming from far, far away Estonia, connecting to you here, and I'm going to talk about one particular engineering journey and choices that we have been making. And my name is Erik Kaju. I come from a company that has a mission of removing borders in the world of finance. So if in geographical world, especially these days, there are restrictive borders between countries, and if people can and they travel, they still need passports and visas. So our goal is to make customers always feel home when they are dealing with international finance, wherever they happen to travel or be. This company is called TransferWise. It's founded by Estonians, and it's a place where I have spent 20% of my life, and I am 30 years old right now. So for the context of the rest of the tech presentation, I'll add just bare facts about us so far. So we launched 9 years ago. So far, pretty much for every year, we have collected about 1 million of customers, and still growing about 50% a year. So because of that, I still consider us as a startup. And we radically cut costs and speed in international finance and remittance. So we move money internationally and help our customers save billions. And for the past 4 years, we have been increasingly profitable. So now let's get over to stats which make more sense and are more relevant for the audience of DevClub. So we are using the microservice architecture, and we have 400 microservices or front-end deployable applications. Actually, like our stack is very colorful, and we are very liberal in terms of allowing our engineers to choose how they want to build TransferWise. But still, we have some quite common stack, which most of teams are using. So 300 out of these services are written in Java, and most likely are running on Spring Boot. And 70 of them are written either in TypeScript or JavaScript. And these 400 deployable applications are built by 478 engineers that work in 86 teams, and every month we are releasing a new version of TransferWise about 3,000 times. So I mentioned microservices. Most likely, most of you have actually somehow encountered it, either worked on it particularly with your own hands, or seen it on internet technical videos and conferences. But just in case, like a small refresher here. So imagine we can have an application which serves some purpose, it has some functionality, and maybe it has some interface to interact with the customer. So instead of having one application, we might be having multiple of them, for example, 3, and they will be small. Each time when we want to release either of them, we don't need to take down 2 others. And also commonly, our applications want to persist something and would like to have some persistent state. So then they also have their own data sources, and so the data is also scattered across multiple locations where they contextually make sense. And also the persistence systems and the principles can be different. For example, different principles of storing the data. And in addition to synchronous communication between applications, often also we need to exchange information asynchronously, maybe in a scheduled manner, or without needing to wait for the response. And then message brokers are being used, or streaming platforms. We use Kafka for that. And then imagine at some point your architecture has been growing, you have been adding more and more services and databases. So imagine at some point we have a small startup with 5 teams, and And then I think like the end goal when rolling out microservice architecture is actually, in addition to that, make team boundaries, define the boundaries between microservices, so that there is a very clear model of code ownership and also access to own and release and merge the code. And for example, we in TransferWise, we are using the loose code ownership, where everyone in the company, every engineer can write to any of 400 applications, but then there are like strictly defined owners for each of those applications that can actually approve the code, merge the code, and eventually release it. And well, we empower our engineers as much as we can, and each of them can also release their own stuff. So here we see the production screenshot of a service which is called DDW Card Management. We see that it's running in 2 Amazon clusters and 3 pods per each cluster. So every engineer that is owner of the service can come and release a new version of it at any given point of time. But when it comes to services that their team doesn't own, then they don't see it in this deployment tooling. So little conclusion by looking at numbers. So we have pizza-sized teams. Most of the teams have less than 5 engineers and can be fed up with single pizza. So also the ownership of those services is quite limited. So only 5 services per team on the average. So every team is owning and needs to deal with quite small portion of TransferWise. And we can also conclude that each team is on the average releasing at least 1 time per day, if not more often. So when Edgars reached out and asked about decisions and if I could talk about them, then it was actually like a little bit difficult in the beginning, because like we pretty much need to do decisions every day. But I try to balance it out between more technical ones and organizational ones. And that's when we were looking at the code ownership and team boundaries, then we also saw that the technical architecture and organizational architecture are mapped one-to-one in TransferWise. So making right choices is very important. I'm going to talk about one sub-product of TransferWise, which is called Borderless. As our mission is to remove borders in finance, we have launched the Borderless account, which is a true multi-country banking solution that never existed before. And our customers can hold money in a lot of currencies, receive money because we are giving out bank account details in many countries of the world. You can send money and eventually also spend on a daily basis with a shiny green, nice debit card. And I will focus on the debit card system today because it's large and complex enough, and it is the latest thing that I have been involved. So we launched a couple of years ago, then we very quickly covered pretty much all countries in Europe and expanded to US and launched business cards and expanded to countries in Asian and Pacific region, and have been adding more currencies and a new card scheme this year, and launched virtual cards, shared accounts, and a bunch of new stuff. So in terms of tech behind all that, after 3 years of being in the making, we have 40 microservices, all of them in Java, 22 databases. We can logically conclude that a lot of services are also like stateless. We have 26 libraries, including front-end applications. And in terms of libraries, we are developing like different stuff for cryptography and payment processing. And it's all being built by 36 engineers. And in addition to that, we have about 30 other roles like product managers, analysts, operational agents, fraud prevention agents, and customer support experts. So decision number 1 was about how we approached developing this novel system. And the point was about isolating completely from any existing systems that we had at TransferWise. So as it happened 3 years ago, it meant that by that time TransferWise was already quite big. It already had modular architecture. It had great observability, traceability of everything. So a lot of tooling. But at the same time, when thinking about building something new, especially like complementing the existing system, I like to draw the analogy with developing the city, and maybe imagine as adding a new city block to the city, like to Riga, for example. And city is very much like a microservice architecture. So we can imagine every building is like a service. So we have different buildings, police station and the airport, and then we have water piping and electricity lines and bus stations. So like all those buildings and structures in the city form some function, and they help the city to function properly. Same in the microservice architecture. But then when you decide to add something new, you usually, like if your system is more than 5 years old, you start to see that like in some places maybe you have some scalability issues because you made some system design flaws that you didn't foresee 5 years ago, and now it is becoming the reality. And like how many times in your life you've been estimating some task and you conclude that to develop that from beginning till the end, it should take about 8 hours. But then in your particular system, you estimate that it will take 12 hours. So you have this 4 extra hours because, and then there is a sequence of different reasons why it's the case. For example, because particularly like in a system which is designed in your way that you are working with, there are some extra complexities. And these extra complexities ideally shouldn't exist. So this is craft or technical depth. And this 4 hours that you add to the development of this feature is the interest that you are paying on the technical depth. So if you were to add your new system and chip it in between the existing buildings in your city that you want to develop, then you will inevitably inherit a lot of that technical depth. So ideally, it can be beneficial if you build it completely independent as much as possible from the rest of the system. Of course, there are some dependencies that need to be in place. For example, most likely you share the customer base. Probably like there are a lot of other things where it is like really tempting to strictly nest those things into each other because it's easier to do this way. But this is the danger of the whole situation. So in reality, you should actually question every such dependency and see if it's actually beneficial, because maybe this dependency in itself already contains craft and tech depth that you will get together by inheriting it. So when we were building the card, we pretty much just started from scratch. Then also sometimes due to whatever reasons, for example, compliance reasons or auditing or the industry standards, even the fresh and shiny segregated system is not enough. For example, in case of banking and building the card processing systems, there is a thing which is called Payment Card Industry Data Security Standard, which dictates very precisely how systems need to be built. And the more services fall into scope, the more painful it is to do audits. So your idea is to take this particular bit, make it as thin as possible, and separate it from the rest of the company completely as much as possible, so that the rest of the company doesn't fall into the scope of these audits. And also, in general, it's a better hygiene if you segregate things, especially things where you are dealing with very sensitive card holder and customer data, and have it on a separate isolated island. So that's what we did. And then actually building things this way, when you say no to those dependencies, you can also actually rethink how to solve those dependencies in a different way, in a more scalable way. And then eventually, by introducing some new concepts to the existing things, you can start defining new org-wide system standards. So instead of inheriting them from the existing system, you will actually build the new ways of achieving the same, and the rest of the company and the organization will adapt it. For example, in our particular real-life card case, every time when you pay with your card online, you have to go through the authentication. So we send the SMS or push notification to the application when you need to approve if it's you or not you making the payment. So it's basically an authentication into the system, but the old one wasn't scaling enough, so we had few concerns, and together with the security team, we developed the new one-time token system. And of course, it was much safer to try it out with the new product. And then when it was proven to work with hundreds of thousands of new customers who don't expect anything, and you are using the beta product, then we rolled it out and started to use it in the rest of the company. Or for example, migration from HTTP JSON-based APIs over to gRPC, or some operational tooling that we used it as an opportunity to improve the rest of the TransferWise and replace parts of the legacy system which had some technical depth. Next step is, so today in the first presentation we heard a lot about monolith life, and it is not always sounding good. However, my strong suggestion is always everything new to start building and designing as a monolithic application. So 3 years ago, when we started building our debit card system as a monolith, the rest of TransferWise was about 80 microservices. So it means that all the engineers that we had, the microservice way of thinking was already a lifestyle. So it was the only acceptable way of building and extending the software. And if you build some new piece which is huge, and you know that it will have a lot of moving parts, then it was really counterintuitive for our engineers to agree to it as a monolithic application. So that reaction and confusion is actually normal. It's a normal reaction. However, let's take a look at why it might be a good idea to start with monolith. First of all, solutions which are built as microservice systems from scratch quite often end up in trouble. While actually the most successful microservice stories usually start with one monolithic application that eventually became too big, and then the engineering team decided to break it up into smaller pieces. And in this monolith to microservice evolution, there is always also a relationship between the productivity of the team and the base complexity of the application. So I borrow this cool image from Mr. Fowler. And there is also another relation to whether the team is building the system as a monolithic application or with microservice architecture. So in the beginning, for less complex systems, the extra baggage required to manage microservices reduces the productivity. But then as the complexity kicks in, productivity starts falling rapidly. And at some point with your monolithic application, you are in a deep problem. But timing matters very much. And while microservice architecture has huge advantages, it is also bringing along some additional complexity for maintaining it and so on. So this premium to the project's cost and risk that comes from the microservice architecture needs to be managed smartly. So then if I was to build something new again, so I would definitely start with a monolithic application once again, and enjoy the higher efficiency in the beginning of the project so I can deliver things to customers faster. Then at some point, and you need to not miss it, we need to start planning the modularization, and then we need to start paying back the decomposition tech debt. So it might mean multiple things. For example, actually splitting the service, or starting with some preparational refactoring work inside of the monolith. And then eventually, as you move forward, you will evolve to a fully modular architecture, and you will be living happily with good and stable boundaries between services. So boundaries or bounded contexts of your domain is the most important keyword. And so important thing that we also like applied, you don't actually need to start from physically splitting anything, because you can actually have like virtual bounded contexts inside the monolith. So whatever like inside of the monolith, you can easily reshuffle this some like tooling like Gradle or any other suitable alternative. So in a single PR of the same repository, you can reshuffle, you can split, you can merge. So you can change everything about like how you design the modular relationships of the application. And same goes for the database as well. And this is like what we did. At some point, we had 45 different Gradle modules in our Spring Boot monolith application. And we've been like playing it around, trying out some temporary setups, merging things back before we actually were smart enough to, at some point, recognize that, okay, this is the perfect split. And same with data. With data, there are also multiple approaches that we tried out. For example, splitting the data first and having a single app multi-data source setup, which actually has proven to be quite complicated and had a lot of pitfalls, and engineers didn't like it too much. But the more common approach is splitting the service, sharing the data source, then making sure that the previous service is not reading or writing anything to the parts of the database that you want to split out. Once you get there with migrations, you can already start migrating this data over to another data source, and then you reach your end goal, which is split service, application logic, and the data as well. Let's go a little bit more technical. So I was thinking of, okay, what else could we talk, which was first time in my life for me. It was the moving away from HTTP REST JSON API calls over FAIN, which were the status quo before that in TransferWise. And we moved over to gRPC. Again, most likely, I mean, it's quite a well-known thingy. Everyone probably has touched it or like seen blog posts about it. But if not, then it's an open source remote procedure call framework, which has been developed by Google. And like it is usually with Google, it has low latency, it is highly scalable, it is distributed. So it's built and created for distributed systems, and it has layered design that allows extensibility. So like authentication, load balancing, logging, monitoring, tracing, you name it. And also it very easily integrates with pretty much any programming language that you can imagine. So it has its own compiler that actually generates the code for you in your language. However, of course, like what it isn't any sort of magic. So it doesn't, it's just an RPC framework, but a really good one. This is what I have learned from personal experience with it. So what can it do? It can help you to define contracts, like API contracts between services, for example. So you can like model your data, you can use enums, you can use collections, you can use like different data structures. And in addition to that, you can also define functions and services. So it will be, of course, generated into a native code of your choice. So for an engineer, it will be a really convenient way of doing those remote procedure calls. So for example, here we have an example. We have a service, or imagine that it's a Java class root guide, and it has a function in it, get feature, which takes one argument. This argument is coordinates of latitude and longitude, and it returns an object which is called feature, and this is a simple object. It has two fields, one string and one boolean. So as a result, if let's say we are using Java, then it will generate all those objects for us. That is exactly the syntax that you need to use, and then give it over to the compiler. So compiler will give you source code that you can use as a library, which will have the same feature, point, person from previous examples, and it will generate the root guide gRPC class with nested implementation class with all abstract methods that you had defined in your proto contract. So as an engineer, you will be actually experiencing like using a framework, but because it gives you the stub class that is responsible for establishing the gRPC connection and making the call to run this function on another server, it's just so convenient for engineers, and when it's applicable, they really like it. Another good benefit is that it also supports streams. So this is also a real life example. So you can, in case you have like high intense and high load data exchange between services, this becomes handy. So to summarize, it's a well-defined and unambiguous. It is really, really efficient, and it supports streaming. So these were requirements that really made gRPC interesting for us. And also, schemas are awesome. So there is no ambiguity. It's strongly typed. Very big benefit is backwards compatibility. So it really solves quite big problem in the industry. Because we don't need complex contract testing flow, which is required with JSON. Since Protobuf and like has its automated generation and packaging of client artifacts, and is also coupled with natural backwards compatibility, even in older versions. On upgrades of client libraries, the upstreams are confident that nothing will break. So this is something that you don't have with your conventional JSON-based APIs, when you actually need to put an effort to validate that nothing breaks when you start using the updated contract. And this is a huge difference when your system is complex and big. And also one number which is important, the actual performance of this thing over classical REST JSON. So we did few tests, and we saw that it is about 8 times faster than REST when receiving the data, and about 10 times faster when sending. It was even more than 10. And maybe to end, so why it's so magically fast? It is so as opposed to the new line delimited plain HTTP1 protocol, gRPC uses HTTP2, which employs binary encoding for frames. So the binary encoding is much more compact and efficient for processing. So there are some additional benefits. It also employs header compression, and it reduces the footprint of HTTP headers, which, like if you think about cookies, can grow quite big. And also, it is not uncommon that headers are often repeated across multiple requests and responses. And last fact, HTTP2 introduces fully asynchronous multiplexing of requests by introducing the concept of streams. And the way how we went for it, everything which is internal between services uses gRPC, and everything which is external, for example, those APIs that are used by our client applications, our iOS, Android, and web apps, and our back office tooling, these are using the old conventional JSON because, well, probably it's more convenient to do client-side applications in the old way. And some optional additional decisions. Well, Protobuf objects, when they are compiled, are just plain old Java objects, nothing special. So we have been using them also for asynchronous messaging with Kafka. So as it can be converted into byte array, so we just create contracts where you can deliver the same information exactly with the same payload synchronously through gRPC or asynchronously through Kafka, which is nice. Also, all of our API calls every time and with every implementation are independent. So including the streaming endpoints, server owns the protocol. So whenever we release the new version of this proto stuff, we automatically publish the client library, which then can be used by engineers of whoever is using this gRPC contract to speak with our server. So it is automatically uploaded to the Artifactory. And for tracing, we use Jagger. So every cool and good and beneficial things that we were doing with old APIs, we could also apply here exactly in the same way. All right, so that was the more technical part, and now I'm delighted to get over to the organizational part, because as we talked about the ownership and the team and system boundaries, these things are quite interrelated. First thing is that TransferWise is consisting out of self-sustained tribes. So we have 8 major tribes, for example, customer journey, financial crime, regional expansion, and so on. If some of them are quite horizontal, like platform support and support, so these are supporting the whole company, or for example, fin crime, then some of them are more oriented to the classical remittance core product that we have had for 9 years. But then when we develop something new, we create tribes so we can have startups inside startups. For example, that's the way how we released the borderless debit card. That's the way how we build TransferWise for businesses, TransferWise for banks, the investments product that is coming out soon. So these tribes are autonomous, and we treat them as independent units within the organization. And they actually consist out of autonomous teams. And teams are self-sustained. They own their own hiring, they own the product and the roadmap, and all roles that are hired to those teams, which then again consist of engineers, mobile engineers, product managers, analysts, designers, whatever this particular team needs. They are also involved in planning what they build. And I would also like to stop on the topic of the role of an engineer. I would like to highlight that the product ownership matters most of all. And definitely, it's not a job as just a developer for writing the code. So we really want our guys to own and decide how and when and what to build. So this is the culture that we have developed in those teams. And reason for that is also that, so I have this specific philosophy behind that. So each of us, you, me, everyone in the audience, sooner or later will switch jobs. So you will move over to some next thing. You won't be working forever wherever you are working right now. And but there is a very big difference what you do next. If someone comes to me and says, "Hey, Erik, I decided to move over to the next company, so I will be working for another company, or I will be working for the competitor." So that's painful, and that's a tragedy, right? But if some engineer comes and says that, "Hey, I am the technical founder of the next startup and building with my friends," so this is something that is definitely worth celebrating, because someone who we worked with is going there and establishing something new that will be improving the world. And with this philosophy, I would like to maximize the chances of our engineers, becoming those next founders of companies. So we try to educate them not only on technical fields, but also on the non-technical tracks. So for example, I push my engineers to manage relationships with partners worldwide, and be involved in negotiating commercial deals, and build the product roadmap together with product managers. So they get used to doing those things which are required when establishing and running a new enterprise. And for example, just like took this picture like one of last trips before the pandemic, where we were having a strategic partnership planning with Visa. And then I told the Visa managers that I'm taking 10 engineers with me, so take your best engineers. And then we were sitting 30 people, 20 of them engineers, and engineers doing whiteboarding sessions, talking about the technology. So it's definitely beneficial when engineers are actually involved and see how decisions are being made. They are also like being part of same conversations, and it's not uncommon at all that our engineers are spending time in same meetings with our CEO and founder of TransferWise. And I think, of course, as we also like give out stock options, then it is probably like quite beneficial that engineers are actually owning what and why they build. And we also have the TransferWise alumni program. So we are organizing those meetings with ex-TransferWisers who go and do something new in the world. So before COVID, it was always a physical meetup, but after the COVID, we started just gathering in Zoom. And a lot of TransferWisers so far in such a short time have also founded quite a lot and well-funded and successful startups. So, we also like to keep the connection with them, exchange experience, and see how far they get. And the final bit is about how we design the team, and maybe it's geographical position and ownership in terms of the product that is being built. So I would call it local ownership with global impact. So of course, maybe like it's like playing with cheats a bit here. TransferWise as such is a global startup, so it has a lot of offices worldwide. And when we're building something new, then we can definitely take advantage of that, and we can be closer to our customers, to the regions where we want to roll out the product, and that really helps us to move really quickly on our regional expansion roadmap. And it works in the following way. So if we have selected 4 development offices for the payment card, which is New York, London, Tallinn, and Singapore, then each office is owning the regional expansion to that market. So they know the best, the culture, the customer, the preferences of the customer. But no one ever wants to work on just localizing some product that someone else built for their market. So engineers usually want to actually build the core, the foundation of the system, something that is used globally. So we have split this core system into 6 most important chapters, and we have given different sites ownership so that they can also focus on something that is used globally by customers. So for example, in case of cards, we have authorization processing, clearing and reconciliation, fraud prevention, card data protection, which is very important, the experience of getting the card, and the experience of spending with the card. So then each site, in addition to the geographical work, also builds the actual really core technology behind the product. And in addition to the benefit of being close to customers, it's also really beneficial of being close to partners. For example, we launched Apple Pay, and so we did it in US, we did it in all European countries that we have, and in Asian and Pacific region. So when doing that, when you work with Apple, you are actually working with different Apples. So in US, you are working with Apple US, in Europe, Apple Europe, and in Asia, Apple Asia and Pacific. So it's a big benefit if you can just, if you are like 2-hour flight away from your partner. And for example, when we were certifying Apple Pay in-app provisioning feature, then well, you actually need to go to Apple engineering facility, spend some time with Apple engineers there, and prove that your system is actually built according to their standards, and so you get the certification. And one of those facilities was in Netherlands. And I have a Dutch colleague, so I checked, hey, it's near your hometown, so go there, take some colleague, spend the week with your family, and come back with the certification. So definitely, when your locations are close to your customers and partners, then you get good results. And then he and his colleague came back, and then we had certified Apple Pay, and then we launched it. So that's the bit about the team and ownership formation. So you can also head over to our Medium profile, which is TransferWise Engineering. There we talk about our philosophy in terms of how to develop the software, how to build product, how to establish the organization. So most likely you can maybe grab some ideas and then implement it in your organizations as well. So thank you very much for your attention, and I hope that you liked it.
Thank you, Erik. So we have already a bunch of questions in the chat. Can you see them?
Yeah. So maybe it will be more convenient if you ask questions.
Yeah, Gatis was first. He asked, how do you do releases? Are they gradual, meaning no affecting 100% of users and promoting as confidence raises? At what stage do you run regression tests, etc.?
Yeah, so most of our releases are gradual. So at least node by node, most applications are running in multiple clusters. So, multiplied by 6. And also our deployment tooling has built-in canary releasing. So if something goes wrong, then we have also automatic rollback feature. For critical systems, we also run database migrations, which are forwards, backwards compatible separately. And in terms of regression tests, we run regression tests with every single build of the service. So we have a requirement to have complete automation coverage, starting from unit tests, integration tests, system-wide tests. So it actually means that our engineers are spending more time writing tests than they spend writing the actual functionality. But then, just like Printify, like the first presenter, Edgar's pointed out, we don't have any manual or even automated tester roles. So it's all being done by our engineers.
Next one was, okay, I lost track. How do you deal with having to combine data together from hundreds of different sources, microservices, to get some sort of combined result? In a monolithic architecture with a single database, you can aggregate and query tons of data quickly at the database level without having to send intermediary results across hundreds of APIs to build the final result.
Yeah, so I guess like there are technical solutions to that in terms of how you architect the system, and also which what is the functionality of specific services that you implement for that. So it's not uncommon that we have some data aggregation services, and they might be completely stateless. So their job is to give us one contract that we need, and then on the background do the communication with any needed services to populate this data. Also, for more complex things like very complicated data aggregation, so we are using also Kafka streams and the streaming service, and there are multiple solutions for that. But to be honest, I don't really, I haven't seen that there are like very big problems with that. So sometimes maybe you will end up making more API calls to services and gathering this data, but it is cheap. It's not taking much time computationally. There is nothing complex about that. In terms of the uptime and the reliability, the whole system is reliable. Actually, it's more reliable when it's cut into pieces. So in real life, you actually don't have this challenge.
Alex says, how do you ensure knowledge transfer from senior developers to junior developers and between teams?
So we have 5 levels of engineers in TransferWise. So classical, junior, mid to senior. I think most of engineers are, between high, mid, and senior. I think the senior is like one of the biggest population. And then in addition to that, we have staff level engineers and principal engineers. And principal engineers are like the role itself is much more extrovert. It is to move between teams, spend a lot of time pair programming and distribute this knowledge across the whole organization. And we try to have principal and staff engineers present in every tribe in TransferWise. And when there is a dedicated role, which is like a big and like very experienced and technically very strong mentor, then such guys, they are like glue, so they keep the knowledge and abilities of the whole team consistent. And we also have internal tech sessions which happen every week where different teams and technical leads and all levels engineers are talking about the latest discoveries, developments. And then we have the annual whole company-wide technical conference. So yeah, probably we just try to work in a way and organize different additional events to make sure that all our people grow. And other things like mandatory PRs and not just saying accept the code. We need for every pull request more than 2 reviews and approvals, and we also have like different levels of ownership. So we have maybe some teams, and then we have some additional like service owners which feedback and review is required. So I guess like it's supervision and making engineers interact as much as possible.
Next question is, so we will spend a few more minutes on questions. It seems that we will not answer all here, and then Erik, is it okay if people ask you directly? You will be here for a while?
Yeah, of course, I will be listening to Hanno with great pleasure.
Good. So next question was by Pavel. How do you handle regional privacy regulation? Example, Europe is GDPR and Korea, USA is their own rules. Probably already answered, but maybe not.
So in terms of the regulations, so we also have quite a big portion of TransferWise, of course, is dealing with local regulation and banking rules. So compliance is something that we cannot exist without, and we are very strictly regulated, both like from financial regulators and other regulations. So, but yeah, we have dedicated people, and whenever we I was showing we have this regional expansion tribe. So whenever we go to some new country, we figure out in details how we need to comply, and then we get licensed in that market, which is also a lengthy process where we need to prove every little detail of how we process data and what sort of service we provide, what we can do and what we cannot do. So yeah, I guess we just invest in having enough people which are specialized to hop from market to market and help the expansion teams with that knowledge.
Okay, few more. So Valdis commented that it's rather common that you can also pull in a gRPC web layer if you need to talk to a gRPC service from the browser, and also dropped a link to GitHub. There is interesting testing regards HTTP to perf. Then Alex is just adding to Christoph's question about data. How do you achieve maintain data consistency, distributed transactions, distributed sagas, and so on?
So the principle is that I will answer to that separately because it might be a longer question, a longer answer actually.
Okay, so I lost my track. Philip was commenting that that probably is the secret sauce that makes Union for more touch startups. It probably could be about your alumni. I didn't catch the moment when Philip said it. And then last question. Is it true that most of TransferWise is run on Amazon Web Service, except on CDN that is delivered by Cloudflare? If so, why don't you use AWS CloudFront?
Good question. I don't have definitely authority and enough knowledge to answer that. So we have this platform tribe in TransferWise, which is owning the vision and long-term kind of design preference of TransferWise on the infrastructure and networking level and on observability and monitoring level. So they build a lot of platform tooling, and actually, most engineers never need to worry about such things. So, for example, everything is so heavily automated. When I was showing you that you can just go and release your service, if needed, you can also just go and provision some additional pods to run in your clusters, and then everything on the background is actually automated because they have built it for us, and this way engineers actually own what matters to the customer. So if we need to add more resource, they can very easily do it. There is a simplified UI for that, but all the complex things in regards to the platform is actually governed by a dedicated, highly skilled team. And yeah, I'm probably fine to admit that this is not my strongest side, so I couldn't elaborate on platform architectural decision like that. I just trust that this is the right way to do it, probably.
Okay, thank you.